Hello, and welcome to today's webcast, Essentials of Micro-Segmentation, brought to you by PDS. Before we get started, there are a couple of housekeeping items that I would like to go over. First, we want to make this session as interactive as possible and encourage you to ask questions at any time using the question and answer box located below the slides window. You can also use the question and answer box to get technical assistance if you should need it. Today's presentation is being presented via streaming audio only, so there is no need to dial into a teleconference. You'll need to make sure that your computer speakers are turned up in order to hear the presenter. You can also fine-tune the audio by using the volume controls inside the media window. The presentation console allows you to interact and customize the layout to fit your viewing experience. You can collapse and expand any window on the console just like you would on your desktop by dragging the corners in or out. In addition, you can also maximize or close any of the windows on your screen by clicking the corresponding icon in the upper right-hand corner on each of the windows. At any time, you can reset the console to the default layout and access additional presentation functionality using the widgets at the bottom of the presentation console. Now, I would like to turn things over to today's presenter to get things started.
Hello everyone, my name is Jeff Willington. I'm a Senior Technical Product Manager with VMware, and the webcast we're going to be talking through today is around the Essentials of Micro-Segmentation. And really what this webcast is for is to help folks understand kind of, what the security benefits of network virtualization are, a little bit around what micro-segmentation is, and how it can help organizations overcome some of the security challenges of today. A little more so than traditional manners. So again, my name is Jeff Willington, and I'm a Senior Technical Product Manager with VMware, and we're going through Essentials for Micro-Segmentation. So the agenda today, we're going to take a look at the kind of the crisis in data center security, a little around why we've been having some of the issues with security from a data center perspective, and some of the things that we can do to mitigate those risks. Why a secure application infrastructure is critical to organizations, because these days application security is sometimes an afterthought, or it's very difficult. It's a very bolt-on type of implementation. Three essentials for the three essential elements of micro-segmentation. We're going to go through secure DMZ, secure end-user computing, and just micro-segmentation in general. And then some three questions about micro-segmentation, and then we'll sum everything up. So step out to the first agenda item here, and why the data center why the data center is in trouble. If you take a look at some of the recent breaches and data center attacks, in the news and so forth, that it's bringing a much more heightened sense of awareness and focus on security within the enterprise. We see lots of information around organizations like Target and Home Depot and Sony, and how those organizations had data exfiltrated, and that the amount of money associated with those, well, some folks will pay fines and penalties and so forth, but there's also damage to the brand itself, where those kinds of costs are almost incalculable over amount of time. But they're very prevalent. They're very they're name brands. And no organization wants to be on the forefront of the newspaper, having paid massive fines, for data exfiltration or loss of outage or anything along those lines. And so, one of the biggest ones that actually happened recently was around Nuance and the ransomware attack that basically brought down their data center infrastructure for several days, to the point of needing to go back and actually do recovery on that environment. So taking a look at some of the industry averages, a lot of this information is from the Ponemon Institute, just around the average cost of a data center outage, and that those costs have risen, nearly $750,000 in 2016 alone. and you always hear the premise that if you haven't been breached, it's only a matter of time, and I think that follows the recent survey expectations. We're basically saying that recent surveys were saying that 75% of organizations are expected to fall prey to some sort of cyber attack if they haven't already been done that way. And so findings like these are the ones that make it, make the need for securing the infrastructure within the data center much more aggressive and much more prevalent. And so how we do it is we're going to start looking at kind of the securing of the infrastructure piece. So let's take a step back here and just kind of talk about a little bit about why breaches are still such a problem. If you take a lot of the recent breaches, data center perimeter security is most organizations are very good at that. They have a hardware-based firewall that sits at the perimeter, and all the traffic going in and out of that system or out of those systems is monitored through that data center firewall. But if something does happen to get inside the data center, that's the point where traditional security methodologies of having multiple firewalls throughout the data center, or not having firewalls at all, creates a problem once you break through the perimeter-based security. And that once you're through perimeter-based security, the attacker will try to find the lowest priority systems that are least likely to be protected as stringently. So if you take the organization may have an external system that a vendor leverages that only that vendor is allowed to leverage, but as soon as those systems are compromised, it makes it very easy to laterally move within the data center as soon as those systems are compromised. And since there's very little security actually placed on those systems, typically those systems are not even monitored that often, just because of the fact of them being a low priority, which gives the attacker even more time to continue to spread out within the environment. So once the low priority system is targeted, they then start footprinting and start trying to find ways into other more high priority systems and ways around within the environment. And since, like I was saying, they're low priority systems, this means that an attacker could be in the network actually doing things and actually be in there for quite a bit of time. And that most organizations that have gone through this problem or found this problem have said that they've found out that the infiltrators had been in their systems for months or weeks, even weeks or months, just by virtue of not being able to identify what is necessarily good and known and not good. So what can we do to stop this, or to at least start putting in controls and security implementations that might be able to help solve this issue? If you take kind of a look at a traditional approach, the traditional approach to using hardware-based firewalls is expensive and it's very complex, right? Because we have to actually, if we want two systems to not talk to each other, say we don't want a web server to talk to the application server, and we're doing it in a traditional approach, that means we would need a firewall between those two systems. And so between those two systems, putting a hardware-based firewall means that all my traffic has to traverse through a hardware-based firewall. Well, that might not be that bad, but as you scale out and there's more and more applications within the data center, if you want to do any kind of security between other applications, it requires more firewalls. And it requires more what we refer to as hairpinning of traffic, where from one virtual machine through the firewall through the other virtual machine, that is traffic that has to hairpin through that firewall. What happens is as you put more physical firewalls and the system scales out, it becomes basically operationally infeasible to continue to manage all of those different firewalls. If you don't have a centralized point of management, there could be configuration problems in terms of, I programmed this security for this application, but then this application needs to talk to this system here, and now I need to configure 2 or 3 more firewalls just to allow those systems to talk to each other. And so traditional methods of leveraging physical devices is just not feasible these days. And then we have virtual firewalls. And virtual firewalls are virtual machines that are basically the service virtual machine or an appliance that runs on the hypervisor for the virtualized workload. They are generally pretty slow because they are by means of being a virtual machine, they are confined to the limits of the networking, the network and the resources given to it by the network administrator. So you may be limited by CPU and RAM and disk speed, and they're also very complicated because as you put multiple firewalls on multiple systems, how do you ubiquitously control kind of all of those different systems? And that's why, taking a look kind of how we would secure application in this infrastructure, how its basic operation is infeasible with today's methodologies. So, what technically is secure application infrastructure? And we believe that it starts with virtualization, right? If you take a look at kind of how VMware and so forth has done virtualization over the years, we have said bring your x86 platform. Your x86 platform, whether it's Dell or an HP or Supermicro or whatever those services are, we take that hardware and provide software-based capabilities on top of that hardware. And we abstract all of the hardware-based components so that we can provide those resources to the workload. And so what that does is it allows us to understand everything that's going on with that system through the entire data path. And so we know how much RAM it's consuming, what's going on with those systems, how much disk and CPU. When you take that to secure application infrastructure and you leverage that with, say, network virtualization, we're now able to see the full path for the system. We're now able to see how the security is set up, how the routing and switching is set up, and if any load balancing needs are necessary, we're able to see those as well. And what we're able to do is take the entire application, compartmentalize it, provide networking-based services from a security aspect, so firewalling capabilities around each of the applications at the virtual machine level. And this allows us very, very granular approach to how we allow two systems on two disparate networks, even on the same network, two different hosts, even on the same host, on how they actually talk to each other. And by putting the security piece into software within the kernel of the hypervisor itself, we are now able to fully see and create a security policy, and that goes along with the same policies that you would leverage for vCPU, the amount of RAM, and the storage that's necessary to run the workload. So we're getting an entire policy that we can now wrap around the application itself and align to specifically what that application is. So, how are we doing this, right? So what's the construct? We're basically taking the traditional approach of putting firewalls, physical firewalls within the data center, or virtual firewalls on each host, and actually putting it into the hypervisor itself. When we place the firewalling capabilities within the hypervisor themselves, we're actually able to put a firewall, a layer 2 through layer 4 stateful-based firewall, on each one of the virtual machines. So if you take it to understand it would be if you had a server and you had a switch, the patch cable that goes from one server to one switch, we're putting a firewall, a virtualized firewall, right in the middle of that patch cable, which means we are able to control all the traffic coming in and out of that virtual machine and create granular-based security at the virtual machine level. What this allows us to do is this allows those mobile workloads, those workloads that are moving around within your data center, all the security moves with it. when you move a machine from one host to another, a virtual workload, the firewall policy is actually going to move with it, which is pretty cool if you go back to the days of vMotion, where if you wanted to move a live virtual machine from one system to another, the system would continue to run without loss of functionality. NSX basically takes that same approach from a micro-segmentation standpoint by putting the firewall rules at the virtual machine itself and allowing that workload to move seamlessly between anywhere within the environment and allow that security posture to move with it. So we're also even going so far as to saying, if you wanted to move these workloads to public cloud, that the firewall and security policy that's associated with that application will also move with the application. So this means ubiquitous control and ubiquitous movement out to cloud-based providers or with internal private clouds that organizations run, and allow those systems to run seamlessly without losing or changing of the security posture. And so when we actually put firewall policies at the VM level for the application, we are reducing the overall attack surface. We are saying that functionally only the web VM can talk to the app VM over certain ports and protocols, which means all of the other ports and protocols that are, all those ports and protocols that could be leveraged to talk to anything else, we're going to block those, and we're only going to allow what's necessary for systems to talk to each other. In the security world, this is referred to as least privilege. But this would be least privilege from a network security perspective, where this virtual machine talks to this virtual machine only over the necessary ports that are necessary for that system to function. And it's going to, and by doing this, we're going to effectively prevent or help prevent how security breaches could happen. If one system is compromised, the only way that system can talk to another system on the network is through the port and protocol that's necessary for it to talk to. We are then going to block all other ports. We can also take in place more granular-based security around specifically different applications. If you've got an HR system, maybe that HR system doesn't need to talk to your point-of-sale system, or doesn't need to talk to your web-based systems. We can provide granularity to the point where HR cannot talk to the web systems at all, regardless. If your web system becomes compromised, the footprint of where an attacker will be able to move is effectively reduced because those other systems are not even allowed to talk to each other at all. So where so that's the basic fundamental concept of microsegmentation, right? Is placing a virtualized firewall within the hypervisor that can't be shut off around each one of the virtual workloads and allowing us the ability to create security policy between our virtual machines. So that gives us some other interesting use cases in terms of what we're able to do with systems. And so let's take the DMZ approach, right? So let's take how do we create a DMZ within an organization, right? And we typically have a workload that needs access or needs exposed to the internet, and sometimes could be functionally, or fundamentally or physically isolated on a completely different network, completely different hardware, and has a very, very tight security posture wrapped around it. In a traditional approach, we might have two physical firewalls with the workload itself between those firewalls. Those systems are then blocked from only allowing that traffic from the exposed VM back into only the appropriate systems that are necessary within the data center. Within NSX and micro-segmentation, if we were able to place a virtual firewall at the virtual machine workload level, technically what we're doing is we are basically saying this virtual machine can only talk to the next virtual machine over these ports and protocols, and we're leveraging a firewall between them. So the concept is the same, except what we're doing is we're removing the physical firewalls from the mix and allowing the workload to move within the data center with a much more stringent security policy placed on it, that allows an organization to not necessarily have to air gap system or specifically build an entire infrastructure, a physical infrastructure dedicated to just DMZ workloads. This allows us to bring those workloads back within the compute data center and still allow DMZ access only to the workloads that are necessary for it. And one of the last use cases here, if you think about it, is around secure user desktop environments. If you think about VDI, so the concept around virtual desktop infrastructure, right, is we created these virtual machines, these virtual desktops for our users to leverage. Where in the past, those physical desktops have been at each one of the desks of the users or in a mobile hands from a laptop perspective. Securing those types of environments is very, very difficult. And so organizations have found ROI and brought those VDI systems back into the data center to run those same virtual workloads technically next to another system within their data center. Those VDI systems may be logically isolated by running in a completely different cluster or on different networks and so forth, but technically they are being run within the data center. So those workloads now fall to the same concepts of traditional approach to how we do micro-segmentation or how we would do least privilege for those environments. If we had to leverage a physical firewall between all of our desktops, if a customer had 10,000 machines, that's a whole bunch of firewalls that were necessary for how you control traffic between those machines. If you take a security-based approach with the firewall within the hypervisor itself, through something like NSX, similar to what we were talking about before, the virtual machine could be a VDI desktop. And the other VDI desktop that's sitting next to it has a similar firewall on it. If you want to provide a means for those systems to not talk to each other, which typically they shouldn't, a VDI session should not necessarily have lateral access to another VDI session. It should only have access to the server workloads that's necessary for the user that's logged in to actually facilitate that communication. So if we can say VDI can't talk to VDI, then any new desktop system that's appropriated into that security group then gets the same security policy as all the others, and no desktops are allowed to talk to each other. If you think about how desktops work now, users will go in and it's not their fault, but they may download a piece of malware or some other piece of malicious software. That virtual desktop would then become infected. If you had no lateral controls on there, that infection could spread to each one of your systems. If you've got 10,000 desktops, it actually becomes easier to spread laterally within the data center. If you take an NSX approach to micro-segmentation by placing a firewall at each one of those VDI systems, then we're not allowing those attacks to spread laterally between the other desktop systems. That one system gets compromised, that system could either be quarantined and scanned or destroyed and rebuilt for the user, and we move on with our lives. Very, very simple, very, very easy to accomplish now from a software-based approach. So a little bit back to, network virtualization is a key enabler for micro-segmentation, right? And this is kind of what I was going back before in a software-defined data center, or VMware's approach to software-defined data center. We're taking those network-based services that you would traditionally buy traditional firewalls for, or routers and switches, and we're virtualizing those concepts and bringing those functions closer to the application workload. Traditional firewalls are inadequate, right? It requires a ton of provisioning time. They are not cheap. A traditional firewall is not a cheap endeavor. Adding, changing, everything requires some kind of constant effort by a network security folks, or the network administrators, or whoever handles the firewall policies. And each one, if you use physical appliances or virtual appliances from that perspective, you have to manage the policy by every one of the VMs that you actually create that policy for, and it becomes very, very difficult and very cumbersome. And so from a network capacity perspective, if you have one firewall and you have 10,000, say 1,000 virtual machines, and you wanted to provide a firewalling or a security implementation for those 1,000 machines, each one of those machines is going to have to hairpin to that one physical device. At some point in time, that physical device is going to run out of capacity. It's just the way it works, right? Those systems are only built to scale so many at a time, and what ends up happening is you have to scale out by adding more systems or scale up by buying a new, bigger appliance, which requires a complete forklift upgrade of the entire physical appliance just to put in a new one. Or we have to add more physical appliances, which then becomes, okay, which workloads do I shift to which appliances and so forth. It becomes very, very difficult and operationally infeasible to work with. So with network virtualization, we have the ability to provide very similar services to how folks are building virtual machines, right? So you provision, you add, you change a virtual machine. We can do all of those same security concepts at the time the VM is built. As the VM moves or a new workload is added or changed, those network benefits, that network security benefit, is moved with the virtual workload. And so the other thing is that we can enforce policy very, very quickly. If you were leveraging something like NSX or network virtualization for security, and there was a system that was found to be in violation of a policy or security posture within your network, you could immediately go to the firewall provisioning system and actually block all the traffic from that virtual machine instantly. And that policy will instantly take place, and you can immediately stop the quote-unquote bleeding, if you will, from that system. And network capacity can be allocated and accessed on demand. If you think about it like this, you may have 1,000 workloads within your system, but you may have 50 hosts that are running all of those systems on it. And if we take a look at kind of a traditional kind of consolidation ratio, like say 20-to-1, we're not expecting that one physical device that we would traditionally have in a traditional environment do all of the firewall capabilities for this for the infrastructure. Each host behaves as the firewall and scales out. So as you add more hosts, you add more firewalling capability to the environment, which means if you move to 2,000 virtual machines, you would add 50 more hosts to accommodate those systems and 50 more hosts worth of network security capability or firewalling capability within the environment. The host only has to participate in leveraging firewalling capabilities for the amount of VMs that run on that host. So 20 machines. So when you think about the traditional firewall where it's one machine doing it for 1,000 VMs, or it's 50 machines doing it for 20 VMs. That allows us to allocate and access all the capacity on demand, and as your workloads scale out and your enterprise grows, it grows with you. So just a quick look in here around some Forrester statistics, finding that 41% of organizations had virtualized their network, while 31% plan to implement network virtualization to address concerns with data security. And this just goes to show you that this is not smoke and mirrors, right? This is something that is very relevant, a very relevant and forefront conversation that organizations are having, and that they are investing time and dollars into. So 3 essential elements for micro-segmentation, right? Persistence. Once the policy is provisioned, enforcement persists despite any changes. So basically, from the birth of the VM to the death of the VM, security will always be enforced. And if the virtual machine increases in size, decreases in size, gets more, there's more virtual machines associated with it, that the same security policies can be implemented for each one of those systems. Say if that system is a web server and needs another web server, and you're going to scale out those workloads. The persistence is the fact that we can take those new workloads that are very similar or the exact same the exact same function and provide the exact same security around that. Ubiquity. So we want to provide security for every workload within the data center, and we want to provide the same capabilities to basically to have the same high levels of security regardless of what the application is. Now, that might not be what an organization needs. An organization may require a specific level of security, say PCI-based security for certain systems and HIPAA-based security for other systems. But with the concept of micro-segmentation and leveraging security through virtualization, we're now able to identify which workloads are PCI-based workloads, which workloads are HIPAA-based workloads, and create policies associated with it. So it doesn't matter which workload it is. We can provide a same level of high level of security or different levels very, very quickly and cost effectively. By putting the security policy on every one of your hosts, you now have the option to provide the level of security that's necessary for the workloads that are running on it. And so the last piece being extensibility, right? We understand that that the firewall that we're putting in within VMware is a layer 2 through a layer 4 based firewall. If there's layer 7 based services, we're offering extensibility to third-party partners to allow them to address deeper security needs through an extensible platform with what we have. Right? We consider NSX to be a platform that pieces from different third-party vendors can plug into to create an even more secure environment based on whatever those third-party vendors are trusted to do. And so I walked a little bit through each one of these, and I'll kind of move forward here just real quick. So, why is a cohesive security strategy so important? Well, again, this is back to some Forrester statistics, but in a study by Forrester, 2/3 of respondents said that full compliance with regulations was achieved in less than 50% of all efforts. Basically saying it's not just about breaches, right? There are security regulations that customers have to and organizations have to adhere to all the time. There's PCI, there's HIPAA, there's FedRAMP. All of these different regulations that are necessary for an organization to function. So if you have to abide by specific regulations, regardless of whether you've had a breach or not, why is having a cohesive security strategy so important? And that is one, to reduce the capability of being breached, but also the ability to do business. If you can't meet these regulations, there are massive penalties that could occur, lots of fines, even to the point of even where an organization could be set to not function or be shut down if they don't adhere to those types of regulations. So some questions, about micro-segmentation that we typically get, from customers around, and that is, does micro-segmentation replace hardware-based firewalls? And the answer to that is absolutely not. Right, so we are in the business of actually going through and creating a perimeter-based security is still vital, right? Hardware-based platforms that control the flowing of simultaneous sessions both in and out of the data center, those are absolutely going to be necessary. But where we are saying that we are able to actually accomplish this is once you're within the data center, the physical hardware-based approach does not scale and is not operationally feasible for actually doing any of the what we refer to as east-west based security within the environment. A perimeter-based firewall handles north-south traffic in and out of the data center. So, is micro-segmentation feasible with, existing technology, right? And I think we've talked about this just a little bit already before, basically saying, with existing tools and technologies, they're not built specifically for micro-segmentation, right? Because there's no context. The solution has no context of what the application is. It has no context necessarily of what the workload is running on the hypervisor. So it becomes very difficult to actually create this ability to abstract the security policy around the application, so that regardless of what the underlying infrastructure is, we're able to say this workload is a web server and it's going to get a web-based policy. There's no context from a physical network perspective. From a physical network or from a firewall perspective, it just looks like another virtual workload. And that legacy, segmentation solutions are prohibitively expensive to implement and maintain. And this is back to putting, physical-based devices within the network and allowing the workloads to move, but then actually going through and having to key in the firewall rules from a security administrator's perspective on every one of those different, firewalls. And so with virtualization taking place within the hypervisor, we're able to create a network hypervisor that runs with the compute hypervisor. And that means we have full visibility and context and understanding of what those workloads are. And we can create intelligent grouping around those workloads within the environment. And as you can see from this slide here, we can say your web servers have a specific policy and your app servers and database servers have a specific policy, but maybe some of these are finance and some of these are engineering. We can create groupings around those workloads so that we know who those workloads belong to, and also the ability to provide security-based postures for each of those different environments, which may be different than the other one. And so the next question is can micro-segmentation be implemented with agent-based security? And we're not saying that agent-based malware and things like that are not necessary for environments, but can micro-segmentation be implemented by agent-based security? No, not technically, because the agent-based systems are running within the user world. And typically, agent-based systems are the first things to be compromised after a system is compromised. Those systems are typically shut down, and functionally means there's no level of isolation that an agent-based system can provide if it's shut down. So if we're able to pull that security down to the hypervisor where it can't be shut down, then that means we're able to remove that agent-based need and actually create security policy that can't be turned off. And we can actually group things around specific, around specific types of services. So the nice thing about this, from an NSX's perspective, is we can do intelligent grouping, right? We can say, is it based off an operating system? We have customers that still have Windows Server 2003 machines running around their environment. I'm sure folks do. We can create a security group that says any system within my data center that has the operating system of Windows Server 2003, I want to place all those systems into a specific security group. You can't do that with agent-based security. It's very, very difficult. It requires a lot of work on the administrator's part to actually do that. Machine name, services, what tier is it? Is it a web tier, app tier, database tier? Regulatory requirements, we were talking about this before, right? CDE, PCI, DSS, all of those different, HIPAA, all of those different regulatory requirements can have different intelligent grouping needs based on those necessary needs. And what we're also saying is that don't just rely on us. If an organization has a tag or has a system that they require a specific security level or security posture on that is not like part of a regulatory requirement, it could be a research environment. It could be something where the organization is intending to protect some kind of intellectual property or something along those lines. you have the ability, organizations have the ability within NSX to create a specific tag specifically for that type of workload, which means you can create your own tags and create your own security policy based on an organization's needs, not just what we have canned within within NSX itself. So, transformative security, we firmly believe that this requires, a software-based approach. If we're able to move networking concepts to software and bring those closer to the workload, we're going to cut down on provisioning time. It's going to allow us to create workloads seamlessly, meaning that as soon as you provide the vCPU and the RAM and the gigabytes that are necessary to run that workload, you provide the firewalling posture, the routing posture, all those different concepts. At the same time you provision that workload. And it's going to bring security within the data center. Instead of relying on the physical external firewall, maybe to do all of the firewalling within your infrastructure, bring security closer to the application and inside your data center where it's easier to manage and doesn't require massive amounts of physical hardware to do so. And you're going to save significant time through automation. We talk a little bit about this, maybe not necessarily under the guise, if you will, of automation, but if you have web-based workloads that are all the same types of web server, every time you stamp out a new web server, if your application scales horizontally from a web server perspective, those web servers should be treated in the exact same fashion. So every time you stamp out a new web server that's part of this application, it should behave it should have the same security posture as the previous ones. So we're able to leverage the ability to create that new workload and automatically apply security posture to that new workload based on the fact that it is a replica, if you will, of an existing VM, which means we can immediately apply policy to it. If it's a new workload, when you go through and actually do the provisioning, we can create the security policy beforehand and attach that policy to the workload as it's being built. That means automation, lack of manual intervention, which is something that's very prevalent within security organizations that causes lots of what we refer to as like configuration drift. So how do we remove that? By moving those things into software, we can remove kind of all of those different things that kind of get in the way of actually putting security in place. So right now, are you ready to take the next step, right? So we can go out here to a couple of these links here and actually start taking a look at reading the blogs that we have in terms of what we're doing with NSX and what we're doing from a secure app perspective. Go out and take a look at some of these links. There's lots of YouTube videos that are on these pages as well that actually take you through the actual process itself. And then get out into the community. The nice thing about VMware is that we have a VMware community platform where other folks that are either getting started or have started down their security path using NSX to secure their applications are already out there talking about it. And it is a great place to start and actually learn what other people are doing and also ask questions. This is a community-based mindset. You can't do it alone. This is a great way to go out and ask questions from your peers in the area of things that you may not be thinking about, or things that you may be thinking about that they may not be thinking about. I hope that was a good overview for everyone, kind of what we're, what you were able to take away and walk away from, that you basically understand kind of the essentials of what we're doing with micro-segmentation and why its unique characteristics make it the preferred approach to doing security within the data center itself. Thank you and have a great day.
I thank you everyone for joining us for today's webinar. PDS is grateful for the opportunity to host this webinar with our partners at VMware, and we're excited to start helping you with next steps. If you're ready to see NSX in action, we'd invite you to get started by scheduling a live demo in one of our technology labs. Our multi-vendor customer demo lab features an extensive state-of-the-art data center environment for live product and solution demonstrations, POCs, testing, certifications, and customized demonstrations. Here you can see VMware NSX and micro-segmentation in action. to ensure it will fit your needs. Please contact us to set up a demo or for more information. If you need more information before you get started, contact us to schedule a conversation with your team and one of our PDS security experts to talk about NSX and micro-segmentation in your environment. Our team of solution architects has extensive experience with these solutions and can help you evaluate them for your organization. And finally, don't forget to join us for PDS Connect 2018 in Madison, Wisconsin, October 17th and 18th. PDS Connect is a 2-day technology conference filled with world-class networking, education sessions, workshops, keynotes, and technology experiences. You can register now at connect.pdsit.net. Thank you for your time, and we hope to talk to you soon.
Thank you for joining us for today's webinar, Essentials of Micro-Segmentation, presented by PDS. If you have any additional questions, a PDS representative would be happy to answer them. Please direct your inquiries to pds@pdsit.net or call 800-966-6090. Again, that email is pds@pdsit.net or call 800-966-6090. Take care.